Okay, welcome to Teaching Science Phenomenally. My name is Heidi Salm. As we were talking a little bit before we're getting started, I love to downhill ski. We live in Wisconsin here, so you have to enjoy all seasons. Otherwise, I don't think you would like living here very much. So we do a lot of outdoor activities, no matter what the season is. I'm a mom of 3. I live just south of Green Bay in a small town called Winneconne. My family loves to road trip. Our goal as a family is to see 50 states before our kids graduate. So we're at about 30 some. We enjoy national parks, love them. Glacier National Park is probably one of our favorites. It's just Montana is just beautiful. We've done lots of things out there for years, and it's just a beautiful state. So if you've never been there, I highly recommend going. In my professional world, I've been teaching middle school science for 15 years. There is my hometown and where my school district is. We are the Winneconne Wolves. We run a K through 12 or 4K through 12 district, all within the Winneconne School District. I'm also the director for the First Education Science Center, which brings me here to you. Our agenda today, we're going to talk about teaching phenomena first, presenting a phenomena. So what does that look like? If you are a science teacher, which I see that you are, you do teach phenomena to some extent, maybe not first. So we'll kind of go over why that's important, what happens after you present a phenomena, how to get the most out of students, and then how to find relevant, good phenomena for your students. And then we're going to take some time to build your own content phenomena. I know when I sit through PD at my school district, I appreciate time to dabble in it and work through it. So that's what I'm offering to you as well. You're going to hear me talk about my participant folder. This is the link to the participant folder. It's also in that original email that I had sent you. So there's a few things that we're going to pull resources from in that folder. This is my target for the day. I have targets in my classroom, so I like just to be on a mission so you know where I'm going with my agenda and my target. Give you a second to take a look. I also love these plants. They're really cool. I teach a bit of biology, so they always intrigue students. So we're really going to focus on that, the modeling and the collaboration and how to work through the after of presenting phenomena. Anytime during this presentation, if you have questions, feel free to pop them into the chat box. If I don't stop talking and you have something important you want to ask, I don't mind if you unmute and fire away. That's why I'm here. So please don't be shy when it comes to asking questions. Sometimes I just don't see them quick enough in that chat box. So after COVID, my students are really struggling with engagement. We did a year of virtual, then we kind of did half on, half off. And I just saw that students lacked those aha moments. And I wanted to bring back to my classroom that engagement that I had pre-COVID and have students become thinkers again and questioners, curious learners, and most importantly, ideas of their own. They're not being dependent on others for their ideas, thinking for themselves, and having confidence without computers. And for me, it went back to phenomena, because phenomena for me has always been something where my students have gotten really excited and really engaged in whatever it was I was teaching. For me, phenomena started many, many years ago. If you are a science teacher, you probably will understand this. There is a storage room or cabinet somewhere. And if you dig deep enough, man, you find some really interesting things in there. So I was digging through some cabinets one time and I came across these spectrum glasses. And I thought, oh, these would be great for my upcoming unit on the electromagnetic spectrum. I'll pull these out and the kids can, have fun just playing around with them and get an introduction to the spectrum. So I've set them on the counter, and you also know how that goes. If it's not at a lab station, which they know are off limits, I had them on my front counter. Students walked in and they just started putting them on. And pretty soon I have a bunch of students wandering around my classroom, grabbing at lights. And if you've ever put on spectrum glasses, they're really cool. They take any light and make a rainbow from them. And students were comparing different light sources, running around and grabbing them. And they started asking me questions like, why is it doing this, Mrs. Salma? I don't get it. What's going on? Does it work with other types of glasses? And all of a sudden there's this big eruption of energy and excitement. And I thought, man, why don't I do something like this every time? Not just a demo, but something quick that they can grasp. So I started to go into deeper and deeper researching phenomena. It's been around for a while. It's nothing new. The shift to teaching phenomena first is a little more in the forefront now than it has been prior. But basically it's, instead of teaching the students the concept, students can then start to unravel things on their own and make their own aha moments. What I think I like the most about phenomena is it's equitable. Here in Wisconsin, we're surrounded by waters and lakes, but we are not surrounded by oceans. And so when I am teaching science or teaching concepts about the oceans, currents and tidal pools and things like that, students that have traveled to Florida on vacation can visualize what I'm talking about. But students obviously who haven't cannot. And they're reliant on a video or textbook in order to gain those experiences. So by teaching phenomena, all students have had the same experience that then they can discuss and dig deeper together on and have those aha moments together because they all had that experience with the initial phenomena together. And I think that's just really important in bonding classrooms and getting kids to buy in. It makes it fair for everybody. Why phenomena first is important is because, to be honest, I used to teach by, introducing a topic, lecture reading, explaining. I might do a demo. Then we would do labs and a little bit of modeling. But what I did was when I would do a demo or there would be some form of excitement where there could have been a phenomena for students, I stole their aha moments. First kid raises his hand, hey, Mrs. Salm, how does that work? And I'd answer them, or I would explain how it worked. And right there, I ended it. And what we want to do, and we're going to talk about today, is letting students uncover the science for themselves and then discover those aha moments for themselves. And it tends to stick deeper in the brain and it allows them to be more engaged in your classroom. First thing, obviously, is to go back to your standards or targets. That's where I always start. So figuring out what standards or targets are linked to the phenomena or finding a phenomena that is linked to those standards or targets. Because if admin walks in and I have a bunch of kids in spectrum glasses grabbing at invisible light, they're probably going to say, what the heck are you doing in your classroom today? So if I can point to the board and say, there's what we're learning about, it is linked to what we're actually supposed to be doing, it just settles better for admin and of course for myself, and it gears my learning towards what students need to have covered. I'm always looking for new phenomena, and Steve Spangler's website is fun. He has all sorts of different things that are on there. A lot of it can be geared towards elementary level, but there are a few things that can stump a high school teacher. So I am going to continue on the majority of this presentation as if you are a learner in my classroom. I feel that this would probably be the most beneficial and effective way for you to experience what it's like to work through those light bulb aha moments with phenomena. So what I'm going to use is these two spheres. I teach middle school, so I need to call them spheres, if you know what I mean. We'll call them the bounce and the no bounce, or it could be flip-flopped or reversed. Basically, what they are is two rubber feeling spheres. One is maybe a little bit more dull. This one has a little more dull color than this one. Their weight is about the same. What else about them? Their texture is the same. So they're pretty smooth. They're not, sticky or anything like that. They're both the same. When you go to push on them, they have about the same firmness. So relatively the same, maybe just the dull appearance. And I will present to the students the spheres like that, and then I'll have a student hold them out and then show students that they weigh about the same, and I'll ask them questions like, do you notice anything else I didn't say? And it allow them to make some observations. So I'll have one student do that for the class. Then what I do next is I will drop these spheres. And since you aren't able to see them, I will show you my youngest son, Jacob, desperately wants to be a YouTube star. So I was telling him, I'll put you in my presentations. You can be my demo guy. So this is Jacob. He's dropping the two spheres onto our countertop. And I will drop them a couple times like this to allow students to see the effects. And as you can see, there's an obvious difference between the two of them. Oop. What happens is my room will then erupt with questions galore of, but Mrs. Song, why is this happening? Or what, is there something inside of it? They'll have all these types of questions that they want to fire away at me. And I've just created the motivation for students to learn the why or how something happens. They get super excited. So this would be the start of your demo, right? You have all these kids at your fingertips wanting to learn and wanting to know something. I think the most important thing that I have learned through teaching phenomena is do not answer the questions. Like I said earlier, I don't want to dash the aha moments or ruin their curiosity. So I have to change the mindset of myself. And I think for teachers, that's something that you have to work on changing, letting the students uncover the answers for themselves. So at this point, what I do is I allow students to have some private writing and thinking time. This allows each student to have a chance to express their own specific questions that they have, kind of get it all out. So what I would like you to do with that pencil and paper I asked you to grab is just to write down a few questions that you have about the spheres and why they reacted the way that they did. And I'll give you a few moments to write down your thoughts. All right, is anyone willing to share in the chat a question that they had or a thought that they had about why the spheres were reacting the way that they were? I think a commonly asked question that students have is there something inside of them that is making them react the way that they're reacting? What I'll then do after I have students write down their questions is I'll have them turn and talk to their neighbor. And while they're turning and talking to their neighbor and explaining their questions to them, I like to walk around and listen and observe. I won't answer any questions, but I listen and observe. This allows me to think and see where the gaps are in their background knowledge. Is it their knowledge superficial? Or do they have a deeper understanding of why or how it's working? So I'll check out their vocab. Ooh, I like this. So what is the temperature of the two? Yep. Does the no bounce sphere have something inside like sand? Yes, those are very commonly asked questions, and those are great questions. So I'll field a few questions from students. And like I said, I will take a look at their background. So what background knowledge do students have about the energy? Are they Are they kind of honing in on things that I need them to be honed in on? Are there performance indicators or standards that I can scooch over because they nailed it? They can explain a certain concept. They got this one, but maybe they don't, understand potential and kinetic energy. Are students asking good scientific questions? Can it be answered with science? And I think that that's an all-level science. It doesn't matter if you teach elementary or high school. Asking good scientific questions is important, and the ability to have it be answered by science and getting rid of those opinions. And are they using the correct content vocabulary? So are there pieces that they're missing? Again, do I need to hone in on certain components? So I'm doing this as they are asking questions and turning and talking to their neighbor and discussing what they think is actually happening. If you teach middle school, and I'm not so sure about science, but usually I have a student when they can't explain things, it's always aliens. And so I have to refer back to, can you prove it with science? So they always get a chuckle out of that. The next component is modeling. I want to be able to see what students' brains are thinking. So I'm going to give them time after they've witnessed this happening to model out what's actually going on in their brain. And I'll ask them to draw a model of how they think it's going to work. This is also a form of pre-assessment for me. So I'm gathering information, what do you already know? And then I have them label the parts of their model. And in the beginning, when I introduce this to students, a lot of our students that view things in black and white, they struggle with the labeling piece because they want to label it right. And I'll tell them, it's your label, you haven't learned things yet. So what would you call this right now? And then I have them write a brief description of what is causing the phenomena to happen. So what I'd like you to do at this moment is to tell me what your brain is thinking. On your piece of paper, if you could please model how you think the bounce and no bounce spheres are working, and to label any parts of your model. So I will do the exact same thing for students. I will pull up this slide. I'll have a video of it reoccurring if I can. It depends on what type of phenomena you're using. And then I'll put these questions on the side so I don't keep getting asked the question, what do you want us to do? And it just makes it a lot clearer for students. So I will give you about 5 minutes or so to draw me a model, label it, and give me a little description of what you think is happening. All right, so I hope you're able to have time to draw your model, get an idea of what it's going to look like in your brain out on paper. In the classroom, this is the point where I would have students turn and talk to their neighbor. They would talk through their model. So what I'm going to do is briefly put you in breakout rooms, and I want you just to talk to your neighbor. I'll put you in like groups of 3 of what you drew and why. All right, as you're coming back, I hope that you have found the time to turn and talk. Students oftentimes enjoy just sharing their thoughts because up until this point, they turn and talked with questions, but they haven't quite had the ability to express their thoughts, their deeper thoughts. We're just going to give it a minute to let the last 3 pop back in, and then we'll move on. All right. So again, at this point, like I said, students have been kind of containing themselves in their thought processes. They've had a lot of questions, but they haven't had the time or ability to really share out their thoughts. This is an example of a student's work that I've had when they were drawing out their thoughts. And I'm assuming many of yours was similar. You probably have more scientific terms, but this is their general thought process. I like to notice the vocabulary that he is and isn't using. Kinetic and potential energy, acceleration, deacceleration isn't part of his vocabulary yet, but the ideas are there. They're just not labeled. So he kind of describes, or at least draws out, what's actually happening with those vocabulary terms. But I can tell that he hasn't had that knowledge yet to be able to label what each of those parts are. If you were with me today, at this point, I would hand out the 2 spheres, so the bounce and the no bounce spheres, and I would have you test them out. So I create groups about 4 seems to work well for this. And then I have students discuss their models like you just did, but now their thoughts. So usually with the pair and share, it's just 2, but I had you in groups of 3. And then I bring them into a larger group. They share out their models, test out their thoughts with things around the room. And if you've noticed, then I've created some tiers for sharing. This helps create a safe environment for question asking. I noticed that students in my classroom are willing to be more vulnerable because they start to realize that all students have questions and they know that no one really knows the answer. And maybe someone might, but that person usually isn't confident and they have nothing to say. I haven't validated that student's thoughts yet. So everyone's kind of in this state of wonder, and that allows students to feel more vulnerable. And I've grown them from private thinking and writing time, so students have time to process themselves, pair and share. I had you in groups of 3 though. Then I bring them into the groups of 4 while actually testing it out. So while students are working in the group, I'm also observing and making note of where their misconceptions are and where I need to camp out on their learning. While they're working in their groups, I allow them to combine a model. So I'll have poster paper around the classroom and they'll take a look at each other's models, pull ideas from it, and create one giant all-encompassing model. As they work together to write a brief description, so merge their thoughts together. And then what I do is I'll have students do a gallery walk. In the classroom, I have them walk around and look at what other students have created for their models, what types of terms they're using, and they make different observations as they're moving around. And again, here I am walking around, checking out misconceptions. So now 4 minds have combined. What am I still lacking at? What do I need to cover more deeply? And what are things can I skim over? When I return, I tell them as a group, they can add or subtract anything they want to their model. So after they've learned things from the groups around them, or just had a better idea of drawing or more details, add it to their model. So at this point, I've had students explore this phenomena as much as possible without any research. And so where do I go from here? You have options. So students will start to kind of design their own experiments. Through their questions, they're already thinking, what's inside the spheres? So that's an experiment. I usually will have one of these sets cut open, and then they talk about surface. So does the surface make a difference if it lands on a hard surface versus carpet? Or does the temperature changes of these, like you asked, does that make a difference with how they bounce? And I'll have students design their own experiments, and I'll show you a worksheet that makes it really easy on your end, so it's unified. I also have them do stations of discovery. So I will take students' general thoughts as we go through and their questions. I'll have a station that will have a pair of these spheres cut open. I'll have a station that has different ways to change the temperature of the spheres. I'll have a station that might change the surface in which they're going to bounce them on, and so on. So there'll be all these different stations that they could rotate through and test things out on. If you like things more structured, that's a really good way to go about it, because you can set things up and it can be more structured. Another option is just to move on with their learning and use this phenomena as their background knowledge. They've all experienced this together, it's equitable, and now we can refer back to it as we're learning the concepts behind the phenomena. It's really up to you. I personally mix it up a lot. Stations of discovery sometimes is the easiest when it comes to building experiments. This phenomena wouldn't be very hard to make experiments with. It wouldn't require so many materials. So this one's a good one where they could design their own. But stations of discovery helps when you're on a limited budget. These two sheets are great for continuing on with their growth of understanding the concepts. You can have students complete them or work as a whole class depending on your students' level of learning. They're great, like I said, for streamlining the work for your students and for yourself when they want to create their own experiments through the phenomena. So if you're familiar with claim evidence reasoning, you might hear the term CER. CER works wonderfully with phenomena and experiments. The question that you would pose up here is, what causes the bounce and no bounce phenomena? Students would, through their experiment, get evidence as to what what's happening to the spheres as they are bouncing on different surfaces, as their temperature changes, what's inside of them, and they jot that down. They come up with their claim as to what's actually creating the phenomena. And then they use the scientific concepts that you are going to teach them later on to pair it with their evidence. So they're going to look at kinetic potential energy, and they're going to look at acceleration, deceleration. They're going to look at the makeup of these two. So what they're made up of. I don't want to give it away. And they're going to come up with their deeper level reasoning. Elementary kids can do claim evidence reasoning, middle school and high school. It's just how much you are requiring of your students. Another great one is the driving questions tracker. I like this one for the elementary levels. They would initially write their questions here that they're wondering about and their ideas of why they think it's happening. You teach them the concept behind the phenomena, and then they would write what they figured out. And that's something that you could do at carpet in front of everybody and work together and fill that out if you do have those lower level students. The next piece is picking a good phenomena. There's so many out there. And sometimes it's trial and error, but picking a good phenomena is pretty important. The things that I like to look for in a good phenomena is the student's curiosity. So are they engaged right away? Did I catch them? It can be investigated. It's not just a one and done. Of course, it's linked to your standards or targets. That's important. And I think the biggest thing that people need to understand is phenomena don't have to be phenomenal. Oftentimes in science, and kids will push you to do it too, like, oh, I really want to explode things, or have these big concepts which are cool and sometimes applicable, but sometimes they're not. And sometimes small things like a video like this could be a really cool phenomena for students to witness. So please don't feel like you need to be an entertainer. You can find really neat things in pictures and in video clips. Here's another example of some great phenomena that doesn't have to be phenomenal. NGSS, and I'll show you some links to these resources later on, has quite a few, and the Wonder of Science website has a bunch. But you could do some really great phenomena with the life cycle of a strawberry. How does it go from a bud and a flower to a fruit that we eat? What's causing this to happen? And it's a great talking point for kids. Surface tension, why does this look like the swimmer has glass over it? What's causing this to happen to the swimmer? So pictures are great for things like that. Another thing is, if you are a coach or an admin or someone that is working with teachers across multiple grade levels. Phenomena, if you find a good one, can cover all levels of learners. So the golf ball is hitting a steel plate in this video. And this concept, this one video, can actually cover multiple areas: kindergarten, middle school, and high school through NGSS. It's just the depth that you would teach each grade would change, not necessarily the phenomena, but the depth that you go into the concepts and the vocabulary that would change. So don't feel like just because you teach a certain grade level, it's too tough or it's too easy for students.
I'm just going to add there too, like in my experience, I taught chemistry and it was always really hard. Like kids always thought it was super hard, chemistry is super hard. But like one of my favorite labs I ever did was with bubbles. And they're like, you mean we get to blow bubbles today? I'm like, yep, all day. All you got to do in chemistry class is blow bubbles. And literally all they did the whole hour was blow bubbles and make observations about the bubbles. And then we went into and it's like really a complex understanding of how the molecule of soap interacts with the air. And it, like we always I always did it when we talked about not polar, non-polar molecules, the distribution of charge, and it got real complex. And they were like, yeah. But it started out as bubbles. So that's one of my favorites that I ever did, because it was just like, we just went down the chemistry rabbit hole, but I used bubbles, and they're like, oh, isn't this kind of lame? I'm like, no, this is so cool. And anyway, that's just my little 2 cents, one that I've always loved.
That's exactly right. You caught them, you had their intention or their attention and engagement through bubbles and kind of acting like a little kid again, and then saying, but do you know, how it's actually working, and they'll buy in. They really do. They buy into the learning when you can grab them with things like that. So yeah, don't sell yourself short on a concept or a phenomena you think is going to be too easy for kids. So how do you find phenomena? Reading through standards and dissecting them is always a great place to start, pulling those key terms out that you're noticing through your standards and targets, and then researching kinetic energy phenomena. Dig in your cabinets like I did. I was telling you, you all probably have some back room or some cabinets within your classroom. I found things from the 1950s in mine. No mercury, so we're good. But you find all sorts of cool stuff within your cabinets. Pictures of an event or having students find pictures. I will now have students take pictures on their way to school of things they see or on vacation, and we'll pose it to the class and dissect the phenomena that they've noticed, which is really fun. They take ownership of that. Demos you already do. You probably have some really, really great demos that you show your students. And maybe you do, maybe you don't. Like I first did, I explained the concept behind it before I let students really get engaged with it. So not answering those questions and letting them stew on that concept a little longer and working through that process I just modeled with you. Classroom aquariums and plants. I have a hydroponics machine within my classroom. We grow lettuce for a community and stuff. And I have a turtle tank and a fish tank. Those lend me phenomena more than you could ever ask for. I have grew pumpkins out of my hydroponics machine, and students couldn't wait to have pumpkins growing in the classroom. And I was growing them up the wall. I trellised them up into my neighbor's classroom, and we were using phototrophism and all that stuff to try and teach kids about that. But they were wondering when the pumpkins were going to start growing. And so we talked about male and female flowers and how pumpkins have male and female flowers. And my phenomena was, it's not what's happening. We're not getting any pumpkins. And so we went through in nature what actually pollinates plants, bees and wind. And so it was cool because students came up with experiments and I kind of let them run with it, but running around the room to try and create wind to pollinate like they do in nature, ultimately they came to the conclusion that a paintbrush will do for pollination. But that was something that, just occurred within my classroom that I could use as a phenomena. And then local phenomena. We have one here where we have one of the largest populations of freshwater sturgeon in the world, and they spawn in one particular spot every year. And so we talk about why sturgeon pick those particular spots and go deep into, the eggs and what they need and all of that type of stuff. So local phenomena is a really cool thing to use too. Building your content phenomena. So I like to have things nice and organized within my Drive folder and for every year, because I don't know, like you, I always try to start off the year well and have everything neat and organized, but by mid-year I'm forgetting to put things in folders. So to keep it all organized, I created a resources sheet for you of places you can easily look for to find phenomena. If you have any that are not on here that you find really helpful, please share them. I'll put them on for other people to see. And then I also created standards and targets aligned phenomena builder. So if you look in your folder, and I will insert that link one more time for you because I believe it's probably at the top at this time. Inside the participants folder, here's that list of resources. NGSS has their own phenomena. So if your district is going off of NGSS, it's nice, they're right there for you. Also, Paul Anderson, who used to do Bozeman Science, but now has a website called The Wonder of Science. He has a great website that has phenomena already found and linked to the NGSS standards, sorry. So if you're looking at chemical reactions, he has videos that are already linked to it, and he will tell you where they belong already, which is great because you have that resource right there and you don't have to reinvent the wheel. There's also a lot of other great ones as you click through and find different phenomena that fit you. Also in the participants folder, I have the phenomena builder. And to help keep things organized and easy for you to find, I have, if you follow these steps, so you just enter in the unit or that you're studying, and then your target or standard that you want a phenomena linked to. And then you can link in your phenomena right here, and you can go over multiple units. Sometimes I end up working backwards on the builder. I'll find a really cool phenomena. I'm like, oh man, what can this fit into? So I can go back and I'll plunk in the phenomena and then search for the standard that it's linked to, because, sometimes you just can't pass up a good one. What I want you to do now, and what I always appreciate when I have PD, is take some time right now to pick an upcoming unit or an upcoming, or one that you've already passed and maybe you're familiar with your standards and targets, and start pulling up phenomena and researching and linking it into this document. If you make a copy of it, then you can keep it for as long as you need. Does anyone have any questions about the document before I give you some work time to get things done?
No question, but just want to say thank you for sharing the resource regarding where to find the phenomena. I was talking with a couple fourth grade teachers, and that was one of the things that they had said, that sometimes with time restraints, it's just hard to find. So I immediately shared that resource with them. Thank you so much. And I'm actually currently working in 2 other classes just to gain some more hands-on with our curriculum. So this is definitely something that will be helpful. So just thank you.
You're welcome. Steve Spangler for the elementary levels has a lot of cool stuff on his website that is linked to phenomena already. So that's another great resource if you're ordering supplies and it comes together. It's really helpful.
Thank you. Thank you. I'll take a look at that too.
And I find, I mean, and this is maybe not for elementary, but for high school kids, like they like tapping into their YouTube brains. Like I saw this on YouTube and I know that maybe isn't for elementary, but for me as a high school teacher, like I saw that, is this really happening? Is it did it? And then that's when you like pull it up. Like I remember one time having a conversation with a kid about, because you can super cool things and then they like freeze, right? And he
Yeah.
like totally didn't understand what was happening. And the YouTube had like done some weird thing and said this was somehow some magical. I'm like, no, it's just super frozen water. And he's like, what? So like was this whole thing we went into about super cooled liquids that I wouldn't have gone into if he hadn't showed me that weird video.
Right. Yeah. I mean, it's really cool what they come up with and what you can use from what they have. Some of my favorite phenomena are stuff that my kids have taken pictures of or brought into me wondering, because then they get their friends involved and the engagement increases and all the good stuff happens. So thank you for sharing that. All right, what I'm going to do is give you about 25 minutes to dabble with this. Start pulling together some resources that you can use tomorrow if you wanted to. Like I said, I always appreciate work time because we all know that there's not enough of that in a day. So like Danielle was saying, we could use some. So here is some work time to get some things done. Feel free to pop back in or ask questions. I'll be here. So ask away, or if you're stuck on one and you need help finding something, I would love to help you.
Heidi, I have a question for you. I know that you had your science conference. It was in March? No, it was in like, it was sometime and I know I couldn't make it. Are you going to do that again next year?
It'd help if I'd unmute.
Okay.
It was in December.
That's right.
And I'll absolutely be running it again. Yeah.
Okay.
So we're going to have it. It seemed to be well attended in December. So I think that's the magical month.
Okay. Because I couldn't make it last time, but I would like to come. I always love all of your stuff. It's really great. So
I appreciate that. Thank you. I think it helps, being in the classroom.
Absolutely.
Getting where kids are at right now. So.
So thank you.
Thank
And
you.
I do have to leave a little bit early, but thank you again. And I will definitely rewatch the whole video. Thank you.
I appreciate it. Have a good one.
Yep.
I hope you found that work time valuable and that you were able to find a few good phenomena that you can use later on or whatever you have coming up. I just continue to challenge you to create those aha moments for your students, but also for yourself, because teaching is a lot more exciting when you have kids that have bought into what you're doing and are engaged. If you have any other questions, please feel free to stick around. I'll be happy to answer them. I'm here, so I'll take as long as I need to answer any of the questions that you have. Thanks again for taking the time to learn with me today. The video for this session will be ready for viewing in about a week. When I receive it from the editor, I'll send you a follow-up email with the video, also a certificate of completion for your records, and a feedback form. I'm always looking for ways to improve or things you think I could add. Like I said, if you have any questions, please don't hesitate to stick around or contact me at any time. I'm happy to answer for you. I hope you have a great night. I just want to honor your time at the end of your day, probably school day. So thank you very much for joining me tonight.